Have you ever noticed a pattern that seems to, I don't know, secretly shape the world around us? I'm talking about everything from the way our savings accounts grow to how populations expand. Well, there's often a hidden mathematical engine at work. Today, we're going to pull back the curtain on one of the most powerful patterns out there, the geometric sequence.
Okay, let's just dive right into this with a question about something we can all relate to: money. This is where you can really see how these seemingly tiny, consistent changes can lead to some surprisingly big results over time.
So here's the deal. You land a job with a starting salary of 26 grand, and they promise you a 2% raise every single year. I mean, 2%, it doesn't sound like much, does it? You'd probably think your salary will just kind of tick up by the same small amount each year, but let's see what really happens.
Okay, so after year one, your salary is now $26,520. That's an extra $520. Simple enough. We get that just by multiplying the original salary by 1.02. That 1 is 100% of your salary, and the 0.02 is that extra 2%. Make sense?
But check this out. This is where it gets really interesting. After year two, you're now over $27,000. Your raise this time was about $530, not $520. So, what gives? Why the extra $10? Well, it's because that 2% is now being applied to a slightly bigger number.
And that right there is the key. The amount of your raise actually gets bigger every single year. We're not just adding a fixed amount. We are multiplying by a fixed factor. This is the absolute heart of a geometric sequence, and it's what leads to that accelerating exponential growth.
So, that fixed factor we just keep talking about? It's got a name, and it is the key to understanding, well, pretty much any geometric sequence. Think of it like finding the sequence's unique DNA.
It's called the common ratio, and we usually just call it R. This little number is the engine that drives the whole sequence. In our salary example, R was 1.02. For every single term, you just multiply by R to get the very next one. It's that simple.
And finding it is incredibly easy. Seriously, you just take any number in a sequence and divide it by the one that came right before it. If you keep getting the same answer every time, boom, you've found the common ratio, and you've just confirmed you're looking at a geometric sequence.
This chart really puts it all into perspective. An arithmetic sequence, that's linear growth. It just adds a constant amount, creating a straight, predictable line. But a geometric sequence, it multiplies. It creates an exponential curve that just skyrockets. It's basically the difference between walking up a ramp and launching in a rocket.
Now, calculating your salary year by year is fine for a little while, but what if you want to know what you'll be making in 20 years? Or the value of a stock after 30 days? I mean, who has time for that? We need a shortcut. And luckily, there's an amazing formula that acts kind of like a time machine.
And here it is. This is the explicit formula for a geometric sequence. Think of this as your fast-forward button. It lets you jump to any term you want, the 10th, the 50th, even the 1000th, without having to do all the calculations in between.
So let's decode this thing. AN is your target. It's the value you're trying to find. A1 is your starting point, the very first number in your sequence. R is that all-important common ratio, the engine of growth. And N is just the position of the term you're looking for. It's a really simple, powerful toolkit.
All right, theory is great, but let's get our hands dirty and actually put this thing to work. We're going to use it to solve a new real-world problem. But this time, just to shake things up, we're going to look at a case of decay instead of growth. So, imagine a stock starts out at a healthy $2,500, but it's losing 8% of its value every day. That means it only keeps 92% of its value from one day to the next. The question is, what's it going to be worth after 10 full days have passed? This is a perfect job for our formula.
First things first, let's pull the key values out of the problem. Our starting term, A1, that's easy, 2,500. Our common ratio, R, is 0.92. Now here's the one tricky part you gotta watch out for. We want the price after 10 days have passed. That's actually the 11th term in our sequence, because the first term is the price on day 0, right? So our N is gonna be 11.
And now for the easy part. We just plug those values right into our formula. The 11th term equals 2,500 times 0.92 to the power of 10. You see? The abstract math suddenly becomes a very concrete, simple calculation. And just like that, we have our answer. After 10 days of decay, that stock is worth about $1,085. In a single step, the formula gave us a precise prediction. It really shows you how powerful this thing is for forecasting.
So beyond just salaries and stocks, why is it so important to understand? Well, because this pattern of exponential growth and decay is frankly everywhere, and it has a massive impact on our world.
I mean, just look at this list. We see geometric sequences all over the place. In finance with compound interest, that's a huge one. In biology with population modeling. In physics when we talk about radioactive half-life. Even in medicine and computer science. Recognizing this pattern gives you a fundamental tool for understanding how all these systems work.
And that really brings us to our final thought here. This isn't just some abstract math concept. It's a new lens for you to look at the world through. Once you know how to spot growth that multiplies instead of just adds, you start seeing it everywhere. So I guess the real question is, where are you going to see it next?